Hello everyone. In this video we will learn about the prismatic joint in the joint components. Prismatic joint is the name in box 2D, derived from the geometric characteristic of parallel sides of a prism. And its other name, translation joint, more intuitively describes the physical motion allowed by the joint, which is to move in a straight line along a specific axis. Moreover, when understanding its working principle, the prismatic joint can be analogous to linear thrust in a motor, compared to the revoluted joint representing angular torque in a motor. This comparison helps us understand different types of joints and their functions. Revoluted joint allow rigid bodies to rotate around a point, like the angular action produced by a motor. Prismatic joints restrict rigid bodies to linear translation along one direction, similar to the linear action applied by a motor. This video only introduces the unique properties of the prismatic joint. Other properties have been explained in the joint common functions section. The unique properties of this joint are angle, enable motor, and enable limit. The angle refers to the direction in which the joint can only translate, measured in degrees. For example, 0 degrees indicates the horizontal right direction, 90 degrees indicates the vertical downward direction, 180 degrees indicates the horizontal left direction, using clockwise angles as directions, and so on. In LayaAir I'd set the angle to 0 degrees, 180 degrees, and 90 degrees, 270 degrees respectively, with a speed of 1, which means movement in the positive direction. Setting it to 0 degrees is the horizontal right direction, 180 degrees represents the horizontal left direction. Similarly, 90 degrees indicates the vertical downward direction, and 270 degrees indicates the vertical upward direction. After checking enable motor, there are two associated properties, motor speed and max motor force. The max motor force usually doesn't need to be set and can use the default value. Its function is the same as explained in the previous motor joint section. The key property is motor speed, which directly affects the speed and direction of movement. The greater the absolute value of the motor speed property, the faster the movement. It's usually set to a positive value. If set to a negative value, it will move in the opposite direction. Next, in LayaAir I'd set the motor speed to 1, 3, and -1 respectively, with the translation direction all set to 0. Run to view the effect. You can see that the larger the absolute value, the faster the movement, and if set to a negative value, it will move in the opposite direction. After checking enable limit, there are two associated properties, lower translation and upper translation. Similar to the revoluted joint, the translation range also has lower and upper limits, with the limit values measured in pixels. The lower translation indicates how far the shortest moving distance is from the anchor point, and the movement will start from lower translation. The upper translation limit indicates how far the longest moving distance can be from the anchor point. Once the limit is reached, no matter how much motor force is set, the movement will not exceed the upper translation range during motion. Next, in LayaAir I'd, without enabling the motor, understand the range of lower and upper limits through mouse joint dragging. When both the lower translation and upper translation are 0, the translation range is locked, and the distance between the two rigid bodies can only be this distance. When the upper translation is 100 and the lower translation is 0, it can only move up to 100 pixels at most. When the lower limit is 100 and the upper limit is 0, it will cause their distance to be smaller than the initial value, and this distance is also locked. For example, it keeps flashing when running, which is caused by the instability of the joint constraint. That's all for this section. Thank you, everyone.